And welcome to the Daily Space Weather Show. Geomagnetic storm conditions have returned once again, as somewhat expected. One more CME on the way. It's expected to arrive late in the day tomorrow on September 27th. We'll tell you all about it and lots more. We'll also show you the most detailed imagery of the sun you'll find in the known universe. Thanks for tuning in to the Smash News Network, least busted name in news. It's only the most comprehensive daily space weather show in the known universe. No big deal. This is the past 24 hours from the closest star here, the Solar Dynamics Observatory, viewing the extreme ultraviolet emissions of hot ionized helium gas. We've got some active regions there setting in the northwest by our Earth scale, a crown prominence hanging out up around the North Polar region, a new sunspot formed in the northeast. Let's take a closer look at that. To the untrained eye, this might look like a reverse polarity sunspot, but it isn't. It is a new, completely separate sunspot group. We'll talk about magnetic polarities later. Here's an even closer view of that. There's that one of the new latest sunspots to get a name today. And we'll zoom back out for the equatorial view. There you go. That active region in the south to the left of our Earth scale is probably the most likely place to see a large solar flare, if not in the northwestern limb, up in the upper right. Again, we do have one new sunspot that's going to get a name in the lower left as well, near our Earth scale there. That one's been an active region for a while. It now shows some dark ombre, so we'll have a small uptick in the sunspot number coming today. And here's a close-up of that little crown prominence hanging out in the southern polar region. Anyway, don't forget to press the like button. If you're new to the channel, press the subscribe button. Congratulations on realizing it exists. It's only the most comprehensive daily space. I think I already said that. There's no competition, folks. There's no competition. There's zero propaganda. Once again, congratulations on realizing the channel exists. Thanks to our new subscribers, we're frankly surprised that you've found it. Press like, press share, press subscribe. Tell your friends and foes about the Smash News Network, least busted name in news. Today's featured product is Do the Math. Yeah, we show our work for the math. 8 == capital D. Hopefully you don't suck at the math. And that might look like empty space, but it's not at all. It features the brightest intrinsic object visible from Earth, the star Deneb. Yeah, it's probably the most important star in the entire sky. We'll talk about that a little later in the video. So if you think space is empty, or you think space is fake perhaps, do the math. Here's the work. 8 == capital D. It's also got the URL for our homepage down there at the bottom of the design, smashomash.com. Also, please visit our affiliate links, which you can find in the description of this video. One of them is our Spaceware link. You know there's an annular eclipse coming to Texas next month. You may want to pick up some eclipse glasses. You can find them on our Spaceware list there at amazon.com/shop/smashomash, also linked below the video, also on the homepage. Or if you're interested in some other space gear, perhaps pick up a electromagnetic radiation reflecting bucket hat. Yeah, that's an electromagnetic radiation reflecting bucket hat. You heard it. And I can prove it. Also, we've got some different patterned gear and so on the Spaceware collection, so check it out. Eclipse glasses, electromagnetic radiation reflecting hats, shirts, pants, and even shoes. You can also find links to the Hemp Lucid shop below this video. We endeavor to keep these videos existent, publicly visible, and free for all to view. So help increase the probability of that by picking up some products from the Hemp Lucid shop, perhaps. You can find CBD and mushroom gummies, capsules. Save $15 on stress, sleep, and immune stacks. Maybe check out the body balms. The cedarwood smells fantastic. I've got some myself, and even CBD for your pets. Again, links below the video to the Hemp Lucid shop. So click the links in the description and help keep these videos existent. Again, you can also find links at smashomash.com. We created a massive web ring for people just like you because we realized that we needed to have our own websites. Smashomash.com. Welcome to the Neo Renaissance. Find our social media, the Redbubble shop, the Amazon shop, the Hemp Lucid shop, even the Golden Cat Productions music label. Original music there under the Spotify link. Hit us up on social media. Again, press like. That's okay, we'll wait for you to press the like button. Or you're new to the channel, press the subscribe button. Then press like, then press comment. Maybe tell us where you're from, I don't know. Anyway, let's take a look at the sun here. Here is the SDO intensity gram for yesterday plus today. Again, we've got two new sunspots here in the east. This one up here in the north, right there. It's already beta class. And this one down here in the south, it's just risen over the southeastern limb. You'll be able to see the magnetic fields there. There's the colorized magnetogram yesterday plus today. September 25th and 26th to date. Let's turn away from space for a brief moment and take a look at what's going on planet Earth, or what's going up from planet Earth. Volcanic activity. Mount Mayan's producing an unknown volcanic ash plume. Please don't pole vault the caldera at Mount Mayan. Mount Ibu exploding, flight level 090. It's a 9,000-foot ash plume over Halmahera, Indonesia. 7,000-foot ash plume from Lubitolo. 14,000-foot ash plume there from Semeru as it explodes. Shishildin produced another major eruption there, up to 38,000 feet, flight level 380 at some point at Shishildin. Now it's dropped down to 20 to 25,000 feet of altitude. So currently, we'll say a flight level 250 over Shishildin in the Aleutian Islands. Next, Popocatépetl exploding, flight level 195. It's a 19,500-foot plume of volcanic ash there over central Mexico. Sangay and Ecuador exploding, flight level 200. Revenador, possible continuous volcanic emissions there from Revenador. Sabancaya, 24,000-foot ash plume. And Villarrica, Strombolian activity continues. Another great example of a caldera to not pole vault. If you're going on a volcanic vacation, leave your vault pole at home. Next, seismic activity. There are the past 90 days conveniently displayed by volcanodiscovery.com, and here are the 5 or greater magnitude quakes of the past 24 hours. There was a 4.1 off the coast of Washington there in the Cascadia fault zone. But as far as 5 magnitude quakes, not too many. First one on the list here is located south of the Philippines. That 5.9 occurred at 1:39 this morning on September 26th. Then off the coast of Michoacan, Mexico, a 5.4 occurred at 6:21 this morning. And that's it. Those are the 5 or greater magnitude quakes. And let's move back to our solar imagery. There is some more from SDO. Here we've put together 171 plus 211 angstroms. You may see a fairly well-defined coronal hole there in the northern hemisphere. Also, some more coronal holes are rising in the east. Believe it or not, they're not super visible yet. There's a lot of plasma that is blocking their appearance. Here's a little closer view of the equatorial portion. And let's talk more solar stats. The 10.7 centimeter radio flux now down to 176 solar flux units. There's the 1-year graph to put that in context. The black line is the radio flux. The red line is the sunspot number, which has also dipped It will come back up a little bit today, again, because we've got at least 2 new sunspot groups in the eastern hemisphere, around the eastern limb. Space Weather Enthusiast Dashboard not forecasting any geomagnetic storms tomorrow night. We are expecting one to arrive late tomorrow on the 27th or early on the 28th, possibly straddling the midnight line there. And it looks like NOAA is expecting continued geomagnetic activity throughout the day today. So geomagnetic unrest forecasted into late tonight there. And again, we did have another minor CME impact. We saw almost KP5 there. Minor geomagnetic storm conditions have resumed, mainly because of magnetic field shift. We'll get to it here in a minute. First, Earth's magnetic moment from space for the past 4 hours. We saw some major aurora jumping off rather unexpectedly. So, I mean, keep in mind, folks, these CMEs were forecasted. There was a coronal hole high-speed stream that missed, but there is the magnetohydrodynamic pressure around Earth for the past 4 hours. Here's Earth's magnetic moment from the ground. We'll show North America as well as the full planet view. And again, we did have some significant aurora. Here's the full globe view. Let's bring this back. Quite significant aurora indeed there. So major geomagnetic perturbations there, major ground magnetic perturbations even around the equator, despite only a minor shift in the magnetism. Let's let that play through again. Check it out, significant magnetic perturbations there around the equator, the Indian Ocean, and so on. This depicts changes to Earth's B field, or geospace delta B. The units depicted here are nanotesla magnetic flux density. Significant magnetic pulses there around the equatorial region. We've also seen significant spikes in the power grid. So unexpected in terms of how strong the impact has been. We'll get to some of the features of that here in a minute. KP index, currently here above 5, so 5.33 is the current planetary K index and average of global geomagnetism. It has actually intensified here in the past couple of hours. And let's go to the real-time solar wind to look at some stats. So we had this long extended period of negative BZ. So a prime example there of, and here's where the strike actually happened, this little CME impact right here. And then the BZ rapidly shifted into a strong negative signal. Total field of 12 nanotesla, BZ of negative 10. And it does look like it is subsiding here. So there's a little shift, and then looks like a continued shift there. However, also an increase in the solar wind density. So another little pulse there. And this is a common thing that you see with CMEs, as coronal mass ejections can be very inhomogeneous. You can have a dense portion followed by a diffuse portion, and then a dense core, and then a more diffuse portion, and then another trailing edge of a CME. It happens all the time. CMEs, they take all kinds of different shapes. Current conditions are about 15 protons per cubic centimeter. For the solar wind density, solar wind velocity here, looks like it's come up to 463 kilometers per second. The plasma temperature has dropped back down, so I suspect this is the trailing edge of the CME. And I think geomagnetic storm conditions are going to subside here. But according to NOAA, there is an increased probability throughout the day today for solar storm conditions, geomagnetic storm conditions to continue. So let's keep that in mind. Goes magnetometer here, showing some spiky readings. Let's show the 7-day to show these latest 2 geomagnetic storms. So some higher lows there showing up on the GOES magnetometers. Next, our top view ecliptic plane field plot. And it looks like indeed the South Pole current sheet is going to be delayed here. It's still several days out. If you look at the latest image, it's now way over there. So this is an indication that we're going to see that southeastern sunspot grow. So there you go. There's a forecast for you. The new sunspot that's about to get named in the southeastern limb is going to grow, or the one in the northeast is going to shrink. So I would suspect the former is going to be the situation. That current sheet there extending significantly. Watch the sector boundary crossing moving way to the east. So expect that southeastern sunspot to grow throughout the day today. There's a forecast based on the magnetic data. And here's our line of sight field plot. So this one depicts the solar B field in blue. It shows north solar polar fields in red and green for south and north respectively. And then the gong magnetogram is the grayscale portion. That's the photosphere's magnetism, which is somewhat separated from the solar corona's magnetism. Speaking of the coronal magnetism, let's look at coronal holes next. And like I said, we've got some additional North Pole-oriented coronal holes here rotating in from the east. Next, we'll look at coronal holes from the SDO's perspective. There is yesterday plus today from SDO, using the lovely Browse Data feature. And let's move to sunspots. So the current situation is sunspot number here, again, dropping down into the, let's see, into the 140s. Something like 143, it looks like, from that graph from the Royal Observatory of Belgium. And there does remain a significant possibility of large solar flares. So the two spots to really look for large solar flares at the moment are going to be the northwestern limb. So up here, and also this sunspot group. At the moment, looking at a 34% chance of an M-class flare from, oh, I meant this sun, not that sun, this sunspot group, this one here. The one that has all these umbrae spread all over the place. That is a very magnetically complex sunspot group. And let's take a look at it. Here's SDO 94 angstroms plus the SDO continuum. So yeah, this group likely to produce large flares, and also this entire northwestern limb. And we are expecting this group down here to grow as well. So it has grown a little bit in the past 24 hours. Don't be surprised to see that continue based on the Gong 2 data that we showed in the top view ecliptic plane field plot. Here we've subtracted 94 angstroms for just the SDO continuum, and look at all the umbrae down there in the south. That is a pretty crazy sunspot. And it's been mostly stable there. So the main changes that we're seeing are this sunspot group up here, this new group forming. It is already beta class at least. And then this group down here is now showing umbrae also. So some potential there increasing in the east. Next, solar flares and energetic particles. And as far as SEPs go, the GOES proton flux here is at baseline levels. So we do certainly have the potential to see spikes in the proton flux. Don't be surprised to see solar energetic particle events here, especially with the high probability of large solar flares right in the Earth-facing portion of the solar disk. We also have a massive number of solar filaments, And we certainly have a magnetic channel in between Earth and Sun, so the potential to see solar energetic particle events is certainly very high. Don't be surprised to see spikes in the ghost proton flux. As far as the X-ray flux, despite a diminishment of the sunspot number, we still see a background flux level of about C1.4, a minor decrease in the past day or so, but still, C1.4 is a significant background flux. No major flares over the past 24 hours, but certainly there is a potential there to see some. So here are some flare wavelengths from SDO 131 plus 94 angstroms. We've already talked about the most likely flare players. And let's talk about some weirder stuff. Yeah, some weirder stuff. So first of all, here's what's going on overhead at the moment. That's the star map over Lehigh Valley, Pennsylvania. And if we advance this, you've got Jupiter, you've got Venus, you've got Mercury, you've got Mars about to rise there. If we continue to advance this, something's going to rise over the horizon. Something that's rather important. There's Vega. And there it is. You see that? There it is. It's Deneb, about to rise in the north-northeast. And what's the significance of Deneb? Well, there are all kinds of significances to Deneb. It is the brightest intrinsic object visible from Earth. It is also the tail of the swan. It is also associated with the myths of storks delivering babies. Yeah, Deneb, the tail of the swan. Cygnus is a very important constellation. So it has to do with the way that the galaxy interacts with the local solar system. And Deneb just happens to be the brightest intrinsic object visible from Earth. So it is a massive X-ray binary consisting of a really hot, bright blue Wolf-Rayet star, which is about 160 times the size of the Sun. If it were in this solar system center where the Sun is, you'd be well inside of it. It would be like the size of Mars's orbit. And here are the X-ray emissions from the X-ray binary. Cygnus X3. So it's a very weird object indeed. It consists of a huge star being orbited at incredibly high relativistic speeds by an even more massive yet really tiny object. So it's known as the Little Friend. Again, those are the X-ray outputs from it, from the Neil Gehrels Swift-Bat X-ray Observatory. And we monitor this daily. It's actually at a rather high X-ray state here at the moment. If you look here, it's around 4 for the baseline. So it's up here in its high X-ray output mode. It is an eclipsing binary also, as the Little Friend moves behind the massive Wolf-Rayet star. It has about a 4.8 hour periodicity, so the speeds of that object are just ridiculous. Here it is from the Chandra X-ray telescope. And we do have an article about Cygnus X3 on smashomash.com/forum. So if you want to read a lot more about it, it is probably the single most important star besides the Sun from the perspective of the Earth and Earthlings. You're actually part of that object's stellar sphere, as it's been sending cosmic rays through your head if you're in the northern hemisphere for your entire life. So it's the only known cosmic ray point source, and it is powerful enough that it is sending material, physical protons, into the Earth all the time. So here's an image of the Little Friend. So right here, you can see where that jet is coming out. That's the Little Friend. This blue jet is a jet of plasma that's oriented directly toward you, and this red jet is one that is directed away from you. So that right there is the only known cosmic ray point source. This is the massive Wolf-Rayet star that object orbits, and it's about a 4.8 hour orbit to go around a star that's larger than about the size of Mars's orbit. So without doing any back-of-the-napkin math, it's moving kind of quickly. And there's a huge disk of plasma in between the star here. This is actually showing X-ray, which is these two bright regions. That's the Wolf-Rayet star. That's the Little Friend in X-ray. And then this blue jet that is radio, depicting blue-shifted material and red-shifted material, moving away from you, moving toward you. Cygnus X3, a.k.a. Deneb. So if you want to read more about that, head to smashomash.com/forum. Hit the Cosmology Forum, Cygnus X3 Massive X-ray Binary Celestial Polestar Deneb. It is a super weird object, to say the least. And let's do a solar system forecast. So here's where objects are today. We'll advance this 1 week. That's where things will be on the 3rd. The 3rd of October, as we continue with your space weather. Today's astronomy photo of the day is pretty berserk also. Check this out. This is a nebula known as the Horsehead Nebula. There's the nose of the horse. And what it is it's complex nebulous clouds of thick dust being illuminated by these hot, bright, blue, very active stars. There's one portion of it. There's another nebula over here. That one's even thicker. Multiple binary blue stars in there. The Horsehead Nebula. That's the astronomy photo of the day. You can go check it out yourself at apod.nasa.gov, and I'll tell you what, the resolution is pretty high. Pretty high indeed. And those are complex molecular clouds full of a soup of different materials. Probably thick enough that a lot of those particles are even neutral. However, most of the stuff in space, folks, is indeed plasma, as it is ionized. Most of that space dust is not living inside of a magnetosphere. And there's a lot of radiation in space. In other words, to call something plasma in space is not really saying very much. It's not a big deal. It only has to be about 20% ionized to be considered plasma in space. So, anyway. Moving on to CMEs. We have some limited data here, unfortunately. But I don't suspect there were any major CMEs since yesterday. Based on the data that we see, there's 60 frames from yesterday. There was a minor one that happened in the northwest, but most of that material collapsed back down toward the chromosphere. It looked like it was going to eject, but it largely didn't. Here are an additional 22 frames from today. And just some minor outflows there, no major CMEs. So here's LASCO C2 and C3. Let's zoom in a little bit closer here. Again, things have been pretty inactive, actually. However, like I said earlier, there is another coronal mass ejection likely to strike late in the day tomorrow, early in the day on the 28th. So don't be surprised to see that. I guess I was the only one that forecasted it. It was a little bit stealthy, though, so in everybody's defense, it wasn't super obvious. It required quite careful analysis, which you can see a couple of days ago on our daily space weather video. Unfortunately, stereo A is not very helpful at all today because it has almost no data since yesterday. It ends at 1509 for the difference imagery and at 109 this morning for the raw coronagraph. So not a lot to see there. Let's take a look at our custom coronagraphs. And you're going to see some gaps in the data there. Also some maneuvering by the C3 there, putting the aperture in the lower left instead of the upper right. And of course, up here you can see a Borg cube appearing on the imagery, right? And there you go, there you go. There's a Borg cube, folks. Oh my God, it's Nibiru. Nibiru is now shaped like a square. That's some signal processing errors, most likely on the data feed. Anyway, here's a little closer view. We've also got the SDO 193 angstroms, and you won't really see very many plasma motions there, so it is looking pretty legit. It's been pretty quiet as far as coronal mass ejections in the past 24 hours. Here's an even closer view, and we've added 304 angstroms to the 193 angstroms SDO imagery there for a little bit of extra detail for the plasma filaments. And let's take a look at filaments. First, the full disk imagery there from SDO. There you go. And you would perhaps notice in the upper right here, the northwestern limb, that there is basically a filament collapse mostly there. Only a tiny amount of that material ejected. And again, we have a very large number of filaments on the solar disk. Check it out. Massive filaments and a large number. So especially this one up here behind the Russell Brand filament. The heck? Oh, looks like that one's ejected. Interesting. Oh, that one must have ejected. Check it out. There's the latest image from 12/12 Universal Time. Yowzers, sometime between 1750 and 12/12. That's suboptimal. Anyway, that filament is gone. Maybe it repositioned itself. We don't see it ejecting, though, so I don't know. So that's a reason to name filaments. And look at all the filaments. It's a crazy number of filaments right now, once again. I mean, yesterday I think we counted 17. Let's stop that. Yeah, so that filament over there is now gone, which is very strange. I don't see that it's ejected. It is far enough toward the limb that it's probably not earthly directed if it did become a CME, but hey, what can you say? You've got the data that you've got. And by the way, thanks to our new Twitter followers. Congratulations on realizing the Twitter account exists. Because there's barely any interaction with any tweets. Because deboosting, censorship, shadow bans, pathetic behavior by Alphabet, Apple, Meta, and Twitter, the four evilest companies in the world. Before we get to bonus features, here are the past couple of hours from the GOES 16 SUVi. And I don't know. It looks like there's a huge filament over here. I don't know what's going on. It's pretty weird. Pretty weird indeed. But we don't see a CME, so hey, what can you say? Here come bonus features. We've got some satellite charging hazards here during this geomagnetic storm condition. Some surface charging hazards here. Significant surface charging hazards by low-energy electrons that build up on the outside of spacecraft. They could cause some communications errors, and we do see some indications of communications errors. So, surface charging hazards there in the Pacific Ocean and in Mexico. So that can affect things like the GOES West. Some surface charging hazards there on the satellite's community dashboard. GOES electron flux here coming up off the floor, but it is still kind of low. That's the past 3 days of radiographic measurements by the GOES 16 and GOES 18. There's the one-year chart to put it in context. And we're seeing the lowest levels we've seen here since back in May. NOAA's forecast here was off by a little bit. And we may see an increased electron flux. We may see an increase when tomorrow night's coronal mass ejection arrives. We'll have to see what happens there. We'll also show how about the layer of the atmosphere where it's measured? The F layer. Here it is in vibrational frequency, or megahertz. Millions of vibrations per second. We can expect to see some low-frequency anomalies here in this. However, it's not heavily scintillated by this most recent geomagnetic storm. This most recent geomagnetic storm hasn't really been that strong. Let's show the anomalygram as well. There is the anomaly in megahertz from a 30-day median. So not as much red as you might expect to see on that during a geomagnetic storm condition. A little bit of an increase there. And you're getting great indication of where the South Atlantic anomaly is located, right there in the center of the South American continent. South Atlantic anomaly there. Super obvious on that imagery. There is also another weaker anomaly here around the Western African equatorial coast, right about there. The African anomaly. So great imagery there of that. Things are looking pretty stable as far as Earth's ionosphere goes. There's 12:15 universal time for the ionogram and 12:15 universal time for the anomalygram. Total electron content is free electrons to about 12,500 miles of altitude. Feel free to pause the video in this frame if you're not familiar with things like the distances to the inner Van Allen belt in miles, or distances to the International Space Station, or the Van Allen probes, or the SDO in miles. Here's your total electron content forecast. And electrons are largely in their expected locations here. Pretty organized despite low levels of electron flux. So there's your total electron content forecast for the planet. And let's show the total electron content anomaly from the 10-day average over North America. And you're going to see a white flash. That is missing data. White is not shown on the scale here. This is literally a count of electrons from ground level to 12,500 miles of altitude. The anomaly from the 10-day average in that figure. We'll close out space weather with the latest intensitygram and latest magnetogram. And what do we have down here? So that sunspot's still very tiny. And let's talk about why that is a new sunspot, not part of this sunspot. It has to do with polarity. So if you look at the polarity of this sunspot, this is North Pole. This sunspot is actually, this is a South Pole umbra, but this one here is a North Pole umbra. That's the leading umbra. So there's no reverse polarity happening there. It's just that the leading umbra is very small on that second sunspot group. Once again, this is the most likely place for large flares besides the northwestern limb, so let's take a look at that. Dag. That is a lot of umbrae. And that is a beta gamma, that is a beta gamma delta class sunspot group. A fine example of it too. This one down here is beta gamma class. You could make the argument that it's beta gamma delta class. And then again, we've got multiple groups up here that are setting. Those are capable of producing large flares as well. Just the proximity to the limb increases the likelihood of large flares. So that is where we'll end our space weather section, and we'll transition into Earth weather, our meteorology segment, with the space layer at nullschool.net. So nullschool.net will show you auroral predictions. There you go. The auroras are continuing here, although we are expecting them to subside shortly based on the way the solar wind is looking. So there are your auroral ovals. And here come Earth weather. There are the surface winds of the east. Shout out to our viewers from this side of the planet. Here are the jet streams from Munda. And for the most populous portion of the planet right here, I heard India's population has exceeded China's. So make sure you press share if you're viewing the videos from anywhere in the world. We need your help to get the content onto screens for some reason. Thanks a lot, YouTube. Here are the jet streams of the central world, Europe, Africa, and the Middle East. Here are the surface winds. Surface winds of the west. And here are the jet streams. Jet streams, they're in control of your weather, unlike mankind. Humans, they can't forecast the weather for 4 days in advance, but they think that they're going to forecast the climate for 50 years in advance. If that's not the height of ignorance and arrogance, I don't know what is. Oh, I know what it is. The idea that mankind can control large-scale weather patterns. That's the height of ignorance and arrogance. Next, we're looking at dust mass, and I think I said a couple of days ago how that tropical low is going to get destroyed. Or was that just yesterday? The tropical low is going to get destroyed by Saharan dust, and there it is happening before your very eyes. Saharan dust being entrained into that low pressure there in the subtropics, and not likely to help increase the strength of that. Next, clouds and fog over the Americas. And look at all the low clouds over the eastern Pacific there. Major low clouds going on for days and indeed weeks. Gloomy, overcast skies over the southeastern Pacific. And here's this low, unable to get spooled up. It's getting chilled by a bunch of sand from the Sahara. Next, your weather.gov map as we zoom into the lower 48. Those are your advisories. Weather.gov if you've got to get your own local weather warnings. The homepage of the National Weather Service, and here come some forecasts. First, the jet stream. Like I said, this is actually in charge of your weather. And we've got an incoherent jet stream coming to the U.S., so that's going to bring some warm temperatures and some convective patterns that are controlling weather as opposed to the jet stream brushing it from west to east. That is the 72-hour GFS jet stream forecast at 250 millibar winds. Here's a temperature anomaly forecast in degrees Celsius. The same model, the GFS 72-hour. So cold temperatures at the coasts and warm temperatures in the central U.S. 72-hour GFS temperature anomaly forecast in degrees Celsius. Next, pressure and precipitation. The same model, the GFS 72-hour pressure and precipitation forecast. As rain continues to fall in wave after wave on the Pacific Northwest. Also, Florida getting hit. And Pennsylvania barely given the opportunity to dry out. Can I ride my bike one of these days, please? Would that be okay? Thanks. Next, lightning. That's where the strikes have been happening. Let's check and see where they are happening. Looks like the Gulf has some lightning. Apalachicola National Forest. There's thunder rolling in. Dag. That's a concentrated little thunderstorm there. Lightningmaps.org. It's good times. By the way, if you enjoy the content and you'd like to see it remain existent, consider becoming a member of the Smash Team. Smashomash.com/Smash Team. You get extra content. I mean, what else can I say? The main purpose is to support the channel and help to offset our massive annual operating loss. So, Smash Team, Smashomash.com/Smash Team. There's a bronze, there's a gold, there's a silver level, there's a gold annual paid-up subscription level. That's the best value. And let's close out the video with the latest U.S. Doppler. Clouds and fog. And water vapor. As the low over Minnesota is now moving down into Iowa. It's bringing a bunch of rain to Wisconsin. And things will be clearing up in Chicago. Once again, there's clouds and fog. And there is your water vapor map. Thanks again for tuning in. Don't forget to press those buttons. Do the thing like and subscribe and share and all of that great stuff. We'll see you soon with more factual content. I know it's very controversial. In the meantime, I'm headed back to the bunker. And while I'm there, I'll have been your host, Dan, a.k.a. Smash and Mash, signing off. And may that solar wind be at your back. I'm going back to the bunker again.